Good morning, class. In this lecture, we will solve few examples of critical path method. So this is the first example. Over here, the activities, precedence and the duration is given. And the question is to determine the critical path and also determine the critical activities. So here the first step is to make the project network. So if you observe, the activity will start with, the project will start with activity A and it will end with activity G and H. So first we'll make the network A. Once A is done, you can proceed with B. Once B is done, you can proceed with C and D. Once C is done, you can proceed with E. Once D is done, you can proceed with F. Now once F is done, you can proceed with H. G and H are the last activities, so they will end here in the last event, H. And once E and F are done, you can proceed with G. Now E and F have to be joined with one dummy activity, G. Now we'll write down the durations of each of these activities. So as we had discussed in the previous lecture, the first step to determine critical path is finding the value of E, that is the earliest occurrence time for an event. The second is to calculate the latest occurrence time of the event, that is L, and third is to calculate L minus E, which is the slack. So the slack, wherever it is 0, is the critical event. Now E has to be taken the maximum of the possibilities and L should be the minimum. We'll start with calculating the E with the forward pass method. E for the first event is 0. E for the second will be 90 plus 0, that is 90. E for third event will be 90 plus 90, 180. E for the fourth will be 190, 180 plus 10. E for fifth will be 180 plus 10, 190 again. E for F will be 190 plus 20, 210. If you observe the fifth event, it's a merging event. So there are two possibilities for E. The first is 190 plus 70, that is 260, and the second is 210 plus 0. The duration for the dummy will be 0. So 210 plus 0, bigger E value will be 190 plus 70. So we'll take 260. For the seventh event, again it's a merging event. So there are two possibilities, 260 plus 80, that is 340, or 210 plus 10, 220. So we'll take the bigger value, 340. Now we'll calculate the value of L. L for the last event is same as the value of E, so 340. L for sixth will be 340 minus 10, 330. L for the fifth event is 340 minus 80, 260. L for the fifth will be 330 minus 20, that is 310. L for the fourth will be 260 minus 70, that is 190. Now L for third could be 190 minus 10, that is 180, or 310 minus 10, that is 300. So we need to take the smaller value, so we'll take it as 180. L for the second is 180 minus 90, 90. And L for the first will be 90 minus 90, 0. Now the third step is to calculate the slack L minus E. Wherever it is 0, it is a critical event. So 1 is a critical event, 2 is a critical event, 3 is a critical event, fifth is not a critical event, fourth is a critical event, fifth is a critical event, sixth is not, and seventh is critical event. So now it is very easy to determine the critical path. So the critical path is one, 2, 3, 4, 5, 7. You can also write this as A, B, C, E, and G. Now the second step is now it is asked you to determine the critical activities. So all the activities which lie on the critical path are critical activities. So the critical activities are activity A, B, C, E, and G. This is the second question. Over here the activities, the precedence and the duration is given, and the question is to determine the critical path using CPM, and the second question is to determine the critical activities. So the first step is to make the project network. Once A is done, you can proceed with B. Once B is done, you can proceed with C and D. Once C and D is done, you can proceed with E. So you need to make a dummy activity here. E is done, F and G. F and G. G and H are the last activities, so they will join into one last event over here. And H can be proceeded with once F is done. So this is how you will represent your network. Now I'll write all the durations. 40. Now the first step is to calculate the E value for every event. E for the first event is 0. E for the second is 40 plus 0, 40. E for the third is 40 plus 40, 80. E for the fourth is 60 plus 80, 140. E for the fifth is either 140 plus 0, that is 140, or 80 plus 60, 140. 140 plus 20, 160. For the seventh, 160 plus 70, 230. E for the eighth is 230 plus 60, 290, or 160 plus 30, that is 190. So we will take the bigger value, 290. The second step is to calculate L minimum. L for the last event is same as the E value, 290. Now for the seventh event, 290 minus 60, 230. For the sixth event, it is 230 minus 70, 160, or 290 minus 30, 260. So we will take the smaller value, 160. For the fifth event, 160 minus 20, 140. For the fourth, 140 minus 0, 140. For third, 140 minus 60, 80, 140 minus 60, 80. For the second, 80 minus 40, 40 minus 40, 0. So now we will determine all the critical events by calculating the slack for each event. So this is a critical event, this is a critical event, critical event, critical event, critical event, critical. So if you observe, all appear to be critical events, so it is very difficult to determine the critical path. For this, you need to take the fourth step. The fourth step is to calculate the total float for every activity. The formula for total float is LFT minus EST minus duration. Wherever the total float is 0, all these activities will be critical. For this, you need to make a table. So as we had discussed earlier, the EST, LST, EFT, LFT for each activity can be determined once the E and L for every event has been calculated. So for the first activity A, EST will be the E of the tail event, that is 0. LST for activity A is the L value for the tail event. Similarly, EFT for the activity A is the E for the head event, 40, and LFT is the L value of the head event. Similarly, you need to identify EST, LST, EFT, LFT for all the activities. Now the final step is to calculate the total float. The formula is LFT minus EST minus duration. So total float for A is 40 minus 0 minus 40, 0. Now the total float for every activity has been calculated. So if you observe, wherever the total float is 0 will be the critical activity, and wherever the total float is non-zero will be non-critical. So now all the total float values are calculated, and if you observe, all the activities are critical except the G activity, because it does not have a 0 total float. So G is not a critical activity. It's very simple to determine the critical path. So your critical path is A, B, C, E, F and H. There are two critical paths. The second is A, B, D, E, F and H. A, B, D, E, F and H. Now to sum it up, we will see few characteristics of critical path. The first is, a critical path is the longest path time-wise connecting the initial and the final event. So what it means is that the critical path is longest in terms of the summation of its duration rather than the number of activities it has. Second, a critical path may run through dummy activity. Third, critical path may not have the maximum number of activities. Fourth, it is possible that a network may have more than one critical path. That is, if two or more paths have the same time duration, which is maximum, then all such paths will be critical paths. Fifth, the addition of activities on the critical path is the project duration. Based on these characteristics, we'll see an alternative way to find out critical path. So if you observe this project network, it has two paths. First is JKMP and the second is JLNP. Now what I have done is I have added all the duration of each of the activities lying on the path. So the first path has a duration of 19 weeks, while the second path has a duration of 14 weeks. So the path with 19 weeks is the critical path since it has the highest duration value. Also, this duration is also the project duration.